periodic classification of elements. When there are number of elements, means we have immense number of elements, and it's a good idea to classify them in order to know their property, to understand their property. So placing similar groups and species together is called as classification. This classification is required in order to understand the property of various elements in a periodic table. So table means the row and column form to represent something. Elements with similar properties are placed in one group to understand them easily. So various scientists, various you can say physicians, they tried to give their best in order to make a table or to classify the elements. So this is a kind of table, and these are the rows and these are the columns. So these rows were called as one was called as group, and this was called as periods. So these are periods and these are groups. So Daubernier tried to represent the element in the form of a table. So he considered three elements in which the atomic mass of the central element, that is 3 element, the central element is the arithmetic mean of these 2 elements. For example, the atomic mass of lithium, sodium and potassium were 7, 23 and 39. If you add 39 and 7 and divide by 2, you will get 23. So the arithmetic mean of 7 and 39 is 23. But the disadvantage is the presence of only few triads. The Daubernier triad, because the triads are unlimited. All of the numbers cannot be, or all of the atomic numbers cannot be seen or cannot be taken as sum of the extremes, and the arithmetic mean is the middle one. Then Newland also proposed a table. This Newland law of octave says that the elements are arranged in such a way that every 8 element, this if you start with 1, you go up to 8, so every 8th element has the same property as the first element. So according to Newland, only 56 elements were found, and which was actually the drawback of Newland laws of octaves. This was not accepted, but it was there are certain theories which gave rise to the table which we are using, and it is acceptable only up to calcium. He also placed some unlike elements in the same slot. This was also a drawback. Mendeleev periodic table. Mendeleev used the atomic masses as the basis of arrangement of the elements in the table. So according to Mendeleev, elements are arranged in the increasing order of their atomic masses, right? So it believes that there was a periodic reappearance. So after some time, there is a reappearance of physical and chemical properties. So what were the advantages of Mendeleev periodic table? He actually left some gap, because he proposed that there were some elements which are still undiscovered. For example, Eka, boron, etc. Noble gases were also accommodated in his table, and he also corrected the atomic masses of certain elements. But there were some limitation of periodic table which is proposed by Mendeleev. The position of the isotopes were not explained, and the hydrogen position is also not fixed. It is placed in group 1a, but the properties of hydrogen matches with halogens also. Modern periodic table. So the modern periodic table came in 1869, and according to this modern periodic table, the properties of element are the periodic function of their increasing atomic number. Atomic number is the basis here. Isotopes are placed at one place in the same group. There is no element between hydrogen and helium, as atomic masses always come in whole number. They will always be whole number, and the atomic number is represented by Z, which is equal to the number of protons in the nucleus of the atom, and it consisted of 18 vertical columns. So this is a table. Then these were called as groups, and these were called as periods. So elements having same number of valence electron, they are placed in same groups, means same columns, and as we go down the group from here to here, the shell would increase. So elements having same number of occupied shells, these are placed in the same group, means same rows, and each element has new electronic shell getting filled. Each period has a new electronic shell getting filled. So the number of elements which are placed in a particular period, it depends on how electrons are filled in various shell. In order to find out the number of electrons in a shell, 2n square formula, this was the formula, this can be used if n is the number of shell. So if this is the nucleus, we have k, this is k shell, l shell, m shell, like this. So k shell has n equal to 1, so 2n square, 2 into 1 square, that is 2. So it has this one, this is a nucleus, this has 2, this has 8. If how to get this 8? 2 into 2 square, that is 8. The valence electrons, these valence electrons in the outermost orbit, it determines the number of bonds which is formed by that element. What are the trends in the modern periodic table? If we see the valence or valency of the electrons, that means the outermost orbit, how it will combine with others, whether it is going to make ionic or covalent bond. So if we move from left to right in a period, means from this point to this point, the valency would increase and then it will decrease, but it remains same in the, if you take downwards, that is in a group, as we move left to right in a period, valence electron increase and it will remain same as we go down the group. As we see the atomic size of the element, it decreases left to right in a period as the nuclear charge would increase because of large charge, positive charge on the nucleus, and atomic size down in a group, down in a group, decrease in nuclear charges, and there will be addition of new shell. The metallic character of the elements, that is the ability to of the atom to lose electron, this is known as the metallic character. So metallic character would decrease from left to right in a period, and this is because of the increase in nuclear charge. But the non-metallic character will increase left to right in a period, and metallic character increases down the group as the size would increase. It can easily lose electrons. The ionization energy, this is the energy which is required to remove an electron from, and if it is in an isolated gaseous atom, we consider it as a isolated gaseous atom. So this is the energy required to remove an electron. So ionization energy increase as we move left to right in a period, and why this is happening? Because of increase in the nuclear charge as we move from left to right in a period. But when you come down the group, ionization energy decreases due to decrease in nuclear charge. But there are certain exceptional cases also. The electropositive character, this decreases from left to right, from here to here in a table, and increases down the group. And why? There is a decrease in metallic character from left to right in a period. The basic character of oxides, this increases down the group as atomic radius increases and ionization energy decreases, and this is because increase in the metallic character or the electropositivity of the element. The acidic character of oxide, we talked about basic character. The acidic character of oxide will decrease as non-metallic character of element will decrease from top to down.